Alright, in this video lesson we're going to take a look at how to find the second derivative with respect to x of an implicit differentiation problem. And we're going to find the first derivative, and then we're going to use that information to help us find the second derivative. So we look at our equation and we notice that there is no product or quotient rule to do, so we're simply just going to take this first derivative here. And with respect to x, we have what? We have 2x is equal to 0 plus 2y and times y prime, because we just took the derivative of y. Of that y squared became 2y, and then we just attach our y prime at the end of that. And now solving for y prime is pretty easy, so let's just do that. So y prime is simply equal to 2x over 2y. And of course we could simplify that, and we could say that y prime is just equal to x over y. So we're going to use this information to find the second derivative. So maybe we should put this in a box so we know we need to use it again. Okay, so now to find the second derivative of y prime is y double prime. And now we notice that in our problem up here we have x on the top and y on the bottom, so we're going to use the quotient rule to solve this. And of course maybe we should define it. We have f is equal to x and our g is equal to y, so f prime is just equal to 1, and thank you. Okay, thank you, buddy. And g prime is equal to 1 y prime, or just y prime. So putting the quotient rule into play, we have, I think I better do it down below, we don't want to run out of space here. So our second derivative is f prime g minus f g prime, which is just y prime, all over g squared, which is y squared. Okay, so you may think you're done, but you notice that in the numerator, this second term here has a y prime in it, and we already figured out what y prime is equal to, right? From up above. So we're just going to plug in x over y every time we have a y prime in this problem. So let's see if we can do that. So we ended up with a y minus x, and then we're going to plug in our y prime, which is just x over y, and the denominator is simply y squared. Okay, and of course if we were to continue to simplify this, we'd have y minus x squared over y times y, or divided by y squared. So we can go ahead and find a common denominator on that y. Of course this is just y over 1, right? So if I multiply it by y over y, that y just becomes y squared minus x squared over a single y. All of that's still being divided by y squared. So of course if you don't see this, when you divide by the big denominator, this y squared, it's the same equivalent statement as taking, whoops, Same thing as taking our numerator, y squared minus x squared, all over y, and multiplying it by the reciprocal, y squared. So now if we put it all together, we can multiply the denominators y squared times y, and ultimately we get our final answer. So our final answer for d squared y over dx squared, our y double prime, is simply equal to y squared minus x squared all over y to the third. Okay, so let's recap what we did. In order to find the second derivative, we had to first take the first derivative, and we found what that was equal to, and we did that right here. Once we continued and found our second derivative using the quotient rule, we ended up with this y prime in the numerator right there, and then we substituted in what y prime was equal to, and then we just used some algebra techniques to clean that up a little bit. Okay, hope this makes a little sense, and good luck with the homework.